Since its introduction in 1992, Ribond's success and acceptance by thousands of dental professionals worldwide has made it the industry standard for dental fiber reinforcement. Ribond remains the preferred fiber reinforcement of independent dental evaluators. Ribond is the top choice of reality evaluators, clinical research associates, and also consistently receives the Dentaltown Townie Choice Award as well. Reality evaluators list Ribond as their preferred fiber reinforcement and reference Ribond's proven and documented history of success, stating, "Ribond has the most research and the longest track record in this category. Its performance has been very good." Clinical Research Associates states a clear preference for Ribond, stating that the importance of ease of use far outweighs cost, and Ribond reinforcement fiber has the best ease of use. The most obvious difference between Ribond and other fiber reinforcements is its superior manageability. Ribond is woven using a patented lino weave. The unique weave is open for easy wetting with the resin, but does not unravel when placed, providing unsurpassed handling characteristics. You can see how Ribond has no memory and will not rebound when bent. Ribond's superior manageability can easily be seen when making a periodontal splint. Here you can see how Ribond stays in position, does not rebound out of the contacts, and easily follows the arch and contours of the teeth. You can also see how this differs from other fiber materials. Loosely braided materials like Kerr's Connect unravel during use. When making a periodontal splint with the loosely braided Connect fibers, you can see how the material spreads apart, doubling in width and resulting in an unnecessarily bulky and uncomfortable prosthesis for your patient. Glass fibers are stiff and have a lot of memory. It is difficult to construct a periodontal splint using glass fibers. You can see how the fibers rebound when trying to adapt them into the contacts, and they do not stay in position. This presentation clearly shows that Ribond has the best ease of use, but don't take our word for it, make your own comparison. Please call or email us and we can send you a manageability sample for your evaluation. Please note that these samples will not be clinically usable, as they will not be cold gas plasma treated and will not bond to the dental resins. If other manufacturers would send a similar sample, the difference will be readily apparent. Manageability not only affects the clinician's ease of use and the patient's comfort, but perhaps more importantly, manageability directly relates to the long-term clinical success. Like a porcelain veneer or an orthodontic bracket, the thinner the bond line is, the better the laminate effect will be. In the case of fiber reinforcements, strength is achieved via design. Layering the fibers against the teeth makes a laminate structure. The closer the fibers are placed against the tooth surfaces, the thinner the bond line will be, and therefore the better the laminate effect will be. When a carpenter glues two pieces of wood together, he uses a clamp to minimize the thickness of the glue between the two pieces of wood. Minimizing the thickness of the glue reduces the chance of cohesive failure of the glue. This same phenomenon explains why we want thin bond lines in dentistry. The same ultra-high molecular weight polyethylene spectra fibers used to make Ribond are also used to make bulletproof vests and lightweight armor protection for military aircraft. Glass fibers are not used for similar industrial applications because they are brittle and not fracture tough. Unlike glass fibers, the strength qualities of the bulletproof Ribond fibers are not compromised when bent. Glass fiber reinforcements behave in a way similar to a pane of glass. Glass is vulnerable to weakening due to stress concentrations. When cutting a pane of glass, for example, the glass is cut by first scoring its surface. The glass then easily breaks at this scratch. The bending of the glass fibers during the manufacturing process for woven glass fiber reinforcements creates stress concentrations in the glass fibers. Under magnification, you can see that some of the fibers are actually broken during this manufacturing process. Because weaving glass fibers compromises its strength qualities, some manufacturers have chosen to use unidirectional configurations. These configurations are effective in reinforcing forces that are parallel to the direction of the fibers, but they are not effective in reinforcing multidirectional forces. This phenomenon can be illustrated with monofilament strapping tape. Like a unidirectional fiber reinforcement, the monofilament strapping tape offers resistance when forces are applied parallel to the direction of the fibers, but you can see how easily it tears when the forces are applied in a direction perpendicular to the fibers. Multi-directional forces are the norm in dentistry and not the exception. Ribond's lock-stitch Lino weave offers multi-directional reinforcement. In effect, each nodal intersection in the weave acts as a tiny knot that prevents crack propagation within the resin matrix between the threads. Loosely woven or braided fibers also lack mechanical interlocking of one thread to the next, and like unidirectional materials will be susceptible to crack propagation within the resin matrix. Some marketers have tried to use simple in vitro flexural strength tests to suggest clinical success, but these tests are meaningless without an understanding of how strength qualities relate to clinical performance. What we call strength is really a combination of many qualities, such as tensile strength, flexural modulus, and fracture toughness. A material might be very strong in one characteristic, but could be very weak in another. A chain is only as strong as its weakest link, and when trying to evaluate the strength of a material, it is probably more relevant to test for the weakest characteristic rather than its strongest feature. For example, a unidirectional fiber material has a high flexural strength with regard to forces that are applied parallel to the direction of the fibers. However, the mode of failure is more likely to be due to multidirectional forces that are applied perpendicular to the direction of the fibers. In other words, maybe a strength test that applies a load perpendicular to the direction of the unidirectional fibers might be more relevant for trying to evaluate clinical success. Flexural strength and flexural modulus are measures of stiffness, and it is true that glass fibers are stiffer than polyethylene fibers. However, any first-year student in structural engineering will tell you that it is easier to design a structure for stiffness using non-stiff materials than it is to design a structure for fracture toughness using non-fracture tough materials. Stiffness is achieved via design by the fibers being placed to make a laminate structure. Ribond's superior manageability allows for the most accurate placement of any fiber reinforcement. Accurate and close placement against the surfaces of the teeth minimizes the bond line and maximizes the laminate effect. In the case of fiber reinforcements, the two most relevant questions would probably be, how fracture tough is the material, and how manageable is it? We would argue that Ribond is both the most fracture tough material available to dentistry and that its ease of use allows for the most effective laminate designs. There is no better test than the test of time, and Ribond leads the fields in its independently documented history of success. Such research includes an independent 42 to 84 month recall study of Ribond periodontal splints by Howard Strassler at the University of Maryland, which showed 0 fracture failures in the 11 patients that were followed during the study. We know of no equivalent independent recall studies by other manufacturers. Ribond's fibers are the standard in biocompatibility. The same polyethylene material used to make Ribond is used in solid form to make the liners for artificial hip and knee joints. Glass fibers are generally not considered biocompatible in industry, which is why workers use respirators when installing fiberglass insulation. Some marketers of glass fiber reinforcements state that you can polish glass fibers and that Ribond cannot be polished. This is partially true. Since Ribond's fibers are so tough, they cannot be cut to the same level as the composite with a burr and will therefore feel fuzzy if polished. Being brittle, glass fibers can be cut with a burr to the same level as the resin and will initially feel smooth. However, as the resin wears away over time, the glass fibers will not wear at the same rate. This will result in sharp protruding fibers that will cause irritation to the soft tissue. Thus, in the long term, neither glass fibers or polyethylene fibers should be polished. Ribond has an indefinite shelf life. This minimizes waste, since there is no expiration date and the Ribond does not need to be refrigerated for storage. Ribond leads the field of dental fiber reinforcements in both innovation and quality. If you have any questions, please contact us and we will be happy to assist you.